I think I've got it here. You might be surprised if you haven't looked at how short this particular exercise is, right? There's what, 7 questions. So here we go. It tells you in question 1 and indicate whether it's an observational or a randomized experiment. So the thing in red is the story. A teacher wants to compare the grade GPA of students who are in sororities to the GPA of students who are not. Right, so you're at university, right? Some people are in sororities, others aren't, and he's wanting to see if there's a difference in the GPAs. Now, is that observational or is it an experiment? The full title for an experiment is randomized experiment. I never use the word randomized. I just call it an experiment. So which is it, observational or an experiment?
Observational.
Correct. What's the clue here that makes you decide that and not the other? Right. Well, if you, let me put words in your mouth, maybe your brain told you, but you can't express it. Aren't the 2 groups self-selected? You can't make somebody a sorority or make somebody not one. Didn't you just find people who were and find people who weren't? And that's the classic feature that an observational study has. You don't control who is in the 2 groups. All you can do is control how many of each group you see, and then you just watch what they do. In this case, the watching is really you collect data on their GPA. If this study was conducted and it was found that people in sororities had a significant lower GPA than people who were not, couldn't you use that as evidence to go to the university and say, we should ban sororities because all they're doing is having parties and they're not studying? And it's, you know, it's bad for them and it's bad for the college, right? You could do that. I think it's a problem doing it, but you could. Now, you remember explanatory and response variables. Explanatory was the x-axis, response was the y. Remember those guys? Well, there's a question about it. Now, question 3. Suppose that a statistics teacher wants to know whether the number of hours spent studying in a group affects their final course grade. In each part, explain whether the research method described is an experiment or observational, right? So it's back to that again. The first one, students keep a log of the hours they spent studying in a group and they report the hours completed. So you just, you know, you collect data that way. Second, students are randomly assigned to study groups. The teacher tells each group how often to meet. And this can vary anywhere from 1 hour a day before the exam to 2 hours per week, right? So let's compare the first one. Students do what they want to do and they tell the professor the data. In the second example, I'm not even sure if you could legally do this, but you go to Ian and say, Ian, 2 hours a week, you got to do it. Brady, 2 hours a month. That's it. And then they say to Krista, Krista, 5 hours a day, you know? So you have all this kind of data. Can you imagine what that might look like? And then you get their GPAs. So which one of those 2 is observational and which one is the experiment?
I'm going to say the first one's observational.
Good. Agreed. So the second one's the experiment. Any clues to which one or why you picked which one you picked?
In the first one, the students are picking for themselves. So from the teacher's perspective, they're only observing. They're not enforcing any stipulations on the experiment or observation.
Good way of saying it. And in the second, there's a lot of control, isn't there? So you're looking for control when you see experiment. You're looking for, you don't really have any control except the people you look at. right? That's about all observational studies can do. I'll leave the third one to yourself. Right, fourth one. Oh, by the way, have you noticed that there's not a number in sight here that's worth talking about? There's no calculations. Suppose an observational study showed that students who got at least 7 hours of sleep performed better in exams than students who didn't. Okay. So that's observational, because they didn't say, Ian, you can only sleep 2 hours tonight in the exams tomorrow. And you say to Mark, you can sleep 10 hours tonight in the exams tomorrow, right? That would be controlling the environment, right? Here, you sleep as many hours as you feel like, and we'll, you know, we'll observe what happened later. So it's clearly observational, right? Now, which of the following are possible confounding variables and which are not? So confounding variable is another explanation for why, you know, the results happened. Here, if you sleep a lot, you get a good grade, and if you don't sleep as much, you get a bad grade, right? That's a observed, we don't have to use that word observed, but that's what you found, right? That's the information that you got. The first one says the number of courses that a student took. Could that be the explanation for why the students' grades were less or more?
I'd say yes.
I could agree with that. If you take a lot of courses, aren't you probably not going to get a lot of sleep?
No,
Right.
probably not, because you have a lot more homework and stuff.
Right. And isn't that the reason for the lack of sleep? And if you take a lot of courses, you probably can't do as well in each one individually, right? Because you can only devote so much time. Have any of you done it where you'll say, I'll never do that again, where you took 20 credits and said, I ain't ever going to do 20 credits in my life again, right? And because your GPA just suffers, right? Even the you know, you just can't physically study for that amount of time and do a good job. So I would say yes. And then they have some explanation, and that would be it. And here's a stupid one. Could the confounding variable be the weight of the student? Right, I don't think that. I mean, maybe people who are overweight sleep more or less than the others, but I can't see that being a major issue. The third one was the number of hours the student spent partying in a typical week. Right, because if you spent a lot of time partying, aren't you probably not going to get a lot of sleep? Also, if you spend a lot of time partying, you're not studying, so you probably aren't going to do well in the exam as well. So a confounding variable, there's an example of one, in my opinion. Now, we've only got, what, 3 more questions and this is over. For each of the studies described, they explain whether it's observational or experiment. So, a group of 100 students was randomly divided with 50 assigned to get vitamin C and the other 50 get a placebo.
It's a random experiment, isn't it?
Yeah, would you agree? In fact, you could put more information into that. Couldn't you say that this is probably at least a single blind, because isn't the way they've said it, the student doesn't know if he's getting vitamin C or not. Now, what they do at the end of that is, you know, check if it prevents colds. So I'm just going to tell you my own personal experience. Show you right now. I'm a great believer in vitamin C. But the jury is out on whether vitamin C helps you to prevent getting the cold. In fact, as far as I know, no vitamins have been proved to do what they do, at least to the satisfaction of the FDA, right? Federal, right? People. Do you know why you can still sell vitamins and say that will help you stop getting the cold? You know, that zinc one that you take when you get the flu and various other pills. Do you know how they get round the fact that they don't really get checked by the medical world? They've already been checked for safety, right? They won't kill you, but for effectiveness, they're not checked. Do you know how they get around it? They're called a food supplement. So you know how like you might put sugar in your cornflakes, or you might put, I know, salt in your hamburger, right? Just a thing that you add to, you know, it's a food supplement. So there is a huge range of vitamins out there. In my opinion, most of them are useless. There's no evidence that they do anything good. But I believe vitamin C does. And that could be the placebo effect, because I am aware of it. But I believe it works. So for what it's worth, vitamin C is good, in my opinion. I think zinc is probably good as well, but to a lesser degree. So in the second story, a random sample of patients who received a hip transplant operation at Stanford University Hospital during the time period 2000 to 2010 were followed for 10 years after their operation to decide whether on its success or failure of it. Observational or an experiment?
Observational.
Right. Didn't people who get hip transplants choose themselves to get hip transplants? Yeah. If I wanted to make that experiment, couldn't I go to this class and say, okay, I'm randomly picking half of you get a hip transplant and the other half you're not getting one. And I'm going to watch you lot for 10 years and see what's going on. I mean, I'm not sure what that would compare, but that would be an experiment. Right, here is question 6. For each of these research scenarios, explain whether you could do a randomized experiment, right? Whether you could do an experiment, a real one. And so the first one is you want to explain whether you could be used to study the relationship between long-term meditation and your blood pressure. And then they give you 5 situations why it is or why it's not possible. And that takes a fair amount of reading, so I'll read it out. It's probably easier to hear me than to read it. A randomized experiment could be done, since it would be possible to randomly assign some people into 2 groups, right? One group would do the meditation and get the blood checked, I'm assuming, and one that wouldn't. Would it be possible to do that? So you ask for 500 volunteers and you randomly split them into 2 groups, and one group does the meditation and you check their blood pressure and the other doesn't. I don't think I need to read the rest. I think I found one of the words. Right? If you can find a way of making it happen, then it's possible. Let me pick one of my own now. Could you do an experiment in America, not in Nazi Germany, right? Could you do an experiment to tell whether overeating reduces your life expectancy? Now, could you do an experiment on it? I know I could do an observation on it, but could I do an experiment on it? Would I be legally allowed to? I don't like that wobbly stuff, Mark. You would do well in Germany. Not that German ever did anything bad. But anyway, the answer to that is no. Morally, you shouldn't, because the only real way of doing an experiment there, when you have to get 1,000 volunteers and randomly put them into 2 groups and tell one group that they have to eat twice as many calories a day as they should, right? And you tell the other group they must never do that. And somehow you're going to have to control their lives, right? So that they stick to the rules. Well, I mean, just think of the moral things. Aren't you forcing people to do something that is distinctly unhealthy, i.e. eating too much? You should never force people, even volunteers, to deliberately do something that is unhealthy. The only way you can really do that one and feel good in your own body is observation, right? Just look at people's weights and how long they live, right? I'm not sure, because weights change, right? But what weight were they, you know, a year before they died? And the reason you would pick it a year before they died is, don't some of the reasons, when you get really ill and die, don't you very often lose a lot of weight? So you don't want to measure the way to death. It's more efficient or more precise to measure their weight, say, a year before they died. That would be an observational. I would never want to do that any other way. Yeah, no, I'll leave the other ones. I think it's fun if you just read them. Pick one of these. Same type of question. Can you do a randomized experiment? So it's a yes, you can, or no, you can. So to study the relationship between age and whether marijuana should be legal, could you do an experiment where you had age and whether they are in favor of marijuana being legal or not?
I'd say it's not possible because it says on the second option where it's impossible to randomly assign the opinions to people.
Oh, interesting. Okay, then that is the end of that. So we are finished the section. So if you give me a few moments, I'll start the next one. And the next one is examining relationships. So it's still in chapter 6. And, whoops, almost got done here. Get my headings written up. I'm ready. So let's start this one. And here we go. Let's look at, in some more detail, stuff we've already done. We're just going to examine it in a little bit more detail. An observational study. There's going to be a retrospective version of that. And a prospective version of that. So in a retrospective observational study, you are looking back at time and finding your data there. So an example of, say, retrospective study. Let's suppose that, made up story. Let's suppose doctors are noticing an increase in a very rare form of cancer, right? Right. So there's, I'll make one up. Ear cancer. I've never even heard of it, right? Because I'm making up. Ear cancer, right? Doesn't happen. Excuse me, my TV's went wonky. Come on. There we go. Lost my picture for a moment. So they got this ear cancer, and it's the kind of thing like 10 people a year get it, right? It's very rare. And normally when something really rare happens, doctors will talk about it, you know? Hey, I actually got to see someone with ear cancer. And then the word goes out. That's funny, but actually, you know, getting a lot of it. Now, a lot could be instead of 10 a year, 100 a year, right? It's still extremely rare, but it's 10 times more than it used to be. And that might set off a retrospective study. And what that would be is they go back and they get data for the last 20 years on how many people have had ear cancer. And you can imagine what that might look like. It would take a fair amount of money. They'd probably have to go to one of the cancer charities and say, we're interested in seeing what's going on. And you've got along here time. And here is today. And they went back to 1990, right? And here is just the number of people diagnosed with that cancer. And it looked like this. Wouldn't you be worried that this is definitely increasing? Would you agree that as time goes on, the incidence of this cancer has noticeably increased? And then what very often happens in a retrospective study is, if this is good evidence, if you're comfortable that this is definitely increasing, wouldn't you then try and say, I wonder why? And then you'd go and you'd look at all the people and see if you could find any commonalities. And what they found is that the cancers weren't equally spread throughout America, right? Randomly 10 different places. But they found that they were in little clumps, little groups. Right? A village that might only have, or a city might, or whatever, a town, can't think of a word here, has 20,000 people in it. And normally you'd be lucky if you get one of them in 20 years, and there's 5. And then they go looking and they find commonalities. And from those commonalities, they might come up with the people who get ear cancer seem to all congregate, mostly at least, near factories that produce pesticides for wheat. And then you say, I wonder if pesticides are used on wheat. And then you go and you look a bit further and you find out that children who live on farms that have a lot of wheat tend to have a higher rate of ear cancer. And you see what you're doing is like a detective story, where you're taking some data and then you're trying to narrow in. And then you can come up with the result is that pesticides are dangerous, right? Because they tend to generate more ear cancer. And then you have to decide what you're going to do about it. Do you ban the pesticides, in which case not as much wheat gets produced because the pesticides are really good at keeping the bugs down? Or do you put safety measures in, right? Ways to try and mitigate it. Examples are, oh God, what was it called? It's got 3 letters. It's sort of like DNT, DTT. DTT, I think it was called. Heard of DTT before? I think it was called that. Now, it might be called DNT, but it starts with a D and it's got 3 letters. They discovered that that was really bad for you, yet it was used especially in third world countries, as an easy way of pest control. You know, mosquitoes and that cause people a lot of problems with malaria. They used DDT. I mean, had aircraft spraying it like everywhere. It was really good at killing mosquitoes. It was also really bad for people. And so you didn't catch malaria, but you got, some other nasty thing happened. So retrospective study is, the thing has already happened, right? And you're just going back and collecting data. In a prospective study, you start now and you follow your subjects. For a number of years. So you would get maybe 1,000 volunteers, right? And whatever it is you're interested in, you would do them. So we've done the marijuana story. There's one in Britain. I'd be amazed if America hasn't done this. If they haven't, they should. In Britain, they have got a group of people. I wish I could remember the name of this observational study, but they've got a large group of people. And what they have done is that they have followed those people for the last 50 years. So every year they fill in a questionnaire And the questionnaire is all about what is your weight, you know, and you know they go to a doctor and they get their blood pressure checked and all sorts of other things. And they've been collecting people's data for the last 50 years, and they're finding out trends, you know, like, well, you already know this, don't you, that America is getting fatter. Right? Typical American is fatter than they were 50 years ago. And they're also finding out about how much alcohol and so on. It's a really, really useful study. The papers that they produce in Britain have found out all sorts of interesting behavioral changes in the population of Britain, and also health changes. You know, we are different, quite markedly different from the people who were 50 years ago, the same age as you, right? I mean, Mark, 50 years ago, people were smoking like there was nothing wrong with it. In fact, there were some adverts that said smoking was good for you. The diet that you had was a lot less processed, right? So you get a lot more fresh and less processed. These things have health effects, you agree? Some are good, i.e. you stop smoking, and some are bad, you eat more processed food than you used to. And the evidence that they've got for that is so good that governments use it to do all sorts of things. Can you remember the food pyramid? Do you remember what the first food pyramid said, roughly? Said, eat lots of carbs. Do you know what the new food pyramid says? Don't eat lots of carbs. So how did they decide that, you know, they thought one was good, but didn't they find out later, you know, it takes 10, 20, 50 years, whatever, it was the wrong way around, right? Don't they now say eat lots of fruit and vegetables? And don't eat lots of pasta and bread, right? So that was the big difference. Really cool stuff. I mean, I do not like governments, as you kind of know, but I do like data. The government tends to be really good at collecting data. They're really biased about telling you what it means. But if you just look at the numbers that they've got, they're really good, which is almost a contradiction. So, are we comfortable about the difference between a retrospective and a prospective? Right. So, I'm going to show you a homework question based on that idea. In question 1, a teacher wants to determine how class attendance during the term affects grades in the final exam. In the first one, how you could do a prospective observational study. Now, you could record attendance data throughout the term. So she's going to collect attendance and final grade. At the end of the term, the teacher would ask the students to remember and report their attendance data. The third one, the teacher would record attendance data throughout the term. At the end of the term, they would ask the students to remember their attendance data, and the teacher would then compare the two sets. Why you would want to do it, I do not know. So I wouldn't even put 3 as a candidate for anything. The fourth one, the teacher would randomly divide the class into 2 groups, one which attends class each day, and the other which skips a day each week. Oh God, I can imagine. I'd like some volunteers. Who wants to skip class and who has to come every day? Oh God, that would not work. Anyway, if anything, wouldn't that be an experiment? Because you're assigning 2 groups and you're telling them what they should do. And then the last one is the teacher would randomly divide the class into 2 groups, one which attends class each day and one which skips day. And the teacher, that's basically the same as the last one. So out of all that group, wouldn't the teacher just record the data throughout the term? Now, what that is a prospective one, isn't it? Because you think about it, she's going to do it this term, won't she actually started at the beginning and work her way through. If you wanted to do the same kind of thing, but as a retrospective study, wouldn't she go to last quarter's class and look up the data of attendance and compare it against her grade, right? So that class is gone, right? It's done. And she went 2 years ago and did that as well. So couldn't she collect data from the last 10 quarters, right, in the past? Retrospective. If she's going to do prospective, can't she only do the one that's now about to happen, right? Quite different situations. And you can choose about which ones are bad or which ones are not. And the next bunch of questions are dead easy because it's a yes, no. Right? Don't you all like yeses and nos? Because if you get it wrong, the next guess is going to be right. Students whose undergraduate major was economics were followed for 10 years after graduation to study the number of different jobs that they took, and then decide whether the following terms applies. Is that a retrospective study? No. Do you see the way that's phrased, time is still to happen, right? They're going to follow them for 10 years. Now, if the thing had said, we've already followed them for 10 years, right? We went back, you know, and found out from the past. That was how I'm reading that one. Right. So let's just stop looking at homework questions and return back to some notes. I'm going to give you a story and you're going to tell me how you could do it in 2 different ways. How you could do it as a retrospective study and how you can do it as a prospective study, right? So suppose I want to compare the consumption of alcohol per week for a student and the GPA, right, that the student got when they, you know, at the end of the term or whatever. So consumption of alcohol per week of a student and the GPA that they got in your class, right? So I'm interested in you lot. I think Ian's an alcoholic and he's going to bomb this class. The reason I said that is because you're not, but you know what I'm getting at, right? So I suspect that Brady drinks too much and that Erin never drinks at all or whatever, right? So I want to know how consumption of alcohol might affect your GPA. Now, if we wanted to do this, you know, as a general college-wide thing, how could you do it as a prospective study, a prospective observational study?
Track down how much alcohol they drink throughout the quarter.
Right, so you give them a little book and you say, I want you to write down how many units of alcohol you do, right, every day, whatever, and then compare it, right? And at the end of the quarter, get their GPA and look at how much they, how much alcohol they took. Let's look at the problems with collecting prospective data. If we did it that way, right, I give you, essentially it's a logbook. So I give all my students a logbook. And I say each day, put in, number of units of alcohol. And then at the end, I'll get your GPA. What might corrupt that data? Why might that data be bad in some way? Krista? Went yellow, so I thought that was you going to talk. You're relying heavily on the students, aren't you here? Aren't you relying heavily on alcohol consumption? Now, if Fred's an alcoholic, do you think Fred's going to tell me the truth? Right? In fact, he might not be telling me the truth, because if you're really an alcoholic, you probably don't keep track of how much you drink. Would you agree? You get drunk and then you drink more and you don't know how much more you drunk, right? You just can't keep track of it. Some people will lie to you because they tell people, they want people to like them, right? Everyone likes to be liked mostly at this. So they may underestimate their alcohol consumption so you don't feel badly about them. Like, well, I thought Mark was more sensible in that, but now I know he drinks 8 glasses a day of alcohol. I don't have the same opinion of Mark as I used to. Yeah, they're frightened of that kind of observation. So one of the biggest problems with this kind of data collection is basically honesty. And in some respects, accuracy. Right. I mean, for instance, Mark, picking on you, not to do with alcohol. What did you have for dinner last Tuesday?
Not sure if I can remember.
Right. Now, you're not lying to me, would you agree? You just don't remember things. Now, if you don't do your logbook for a week and then you have to catch up on it, aren't you probably going to make the same errors? I don't know what I had on Monday, if I had anything to drink on Monday, right? So accuracy is a problem, right? Accuracy is not the same as honesty. Isn't honesty, you know the right answer, but you're lying about it. And accuracy is you're not deliberately lying, you just can't really, put your finger on it. That would be a prospective study. Now, if you try to do a retrospective study, I think in the story I've just gone, that's going to be quite difficult, right? So I'm going to go back to a class I had in the fall. And I'm going to go and contact all those students and say, hey guys, I'm trying to collect data on alcohol consumption and their GPA. I know their GPA, right? Because I've got that, right? So I'm pretty sure that's accurate data. Can you imagine that if you tried to do that retrospectively, wouldn't most people have a real hard time if all I asked them for was, what was the average number of units of alcohol you consumed last quarter, right? Since most people can't remember what they had for dinner last week, what's the chances they remember how much they drank last, 4 months ago, right? So in a retrospective study, you can very often have the same 2 problems. But I think the accuracy one will be much larger. Would you agree the accuracy will be a lot poorer if you ask people what they did a month ago or 10 months ago? At least if you're doing it as a prospective study, they should be doing it every week, right? So the accuracy might be a little bit out, but that is a lot out. Now, if your data is not good, won't your conclusions be bad? Right. If I'm not collecting good data on how much units of alcohol someone takes, isn't it going to directly affect how the conclusions I can make based on it? So we are kind of stuck with that problem. Here is another story. Lifetime exposure to sun and the risk, which is basically what percentage get skin cancer. So we are interested in exposure to the sun and the percentage chance that you actually get skin cancer. So if you wanted to do that as a retrospective or a prospective, right? If you wanted to do a retrospective study, couldn't you just go and find some doctors and get some data on skin cancer, right? Patients who have skin cancer, and then somehow try and imagine their exposure to the sun. Now that'd be difficult, but I guess I could do it. If somebody lived in California all their life, right? So you got 200 people, right, who lived in California for their entire life. Couldn't you find out what percentage of those got skin cancer? And I'm assuming that California has a lot of sun, so that would be high sun. Couldn't you also go and find people in Alaska who probably don't get as much sun and find out the incidence of skin cancer there, right, and so on. So you could kind of do it. Would you agree it'd be hard? You could find places with lots of sun and see what the percentage of cancer was, and so on. If you wanted to do a prospective study, couldn't you get 1,000 volunteers and basically have them record the amount of exposure to sunlight that they get? In other words, how many hours of the day do you spend outside? Right, that would be one measure of it during the sunshine, right, not during the night. And then follow them for 50 years and figure out what percentage got cancer. Right, that would be a way to do that. So prospective, you start today and you follow them till the end. Retrospective, you go back in the past and collect data for something that's already happened. And that is a good point for us to say, take your last name and attendance.